In this video, I'm going to discuss the topics of domain and range, and also going to go through how do we calculate the domain and range of two different functions. Now, first, let's start with a definition. Let's start with domain. Now, the domain is the input values of a function. Now, if you remember, a function is a special type of equation where each input has exactly one output. Now, these inputs are a lot of times referred to as the x values. If we are graphing on a standard xy coordinate plane, the x values are the inputs and the y values are the outputs. So, for example, let's say I had a table x, y. My x's are 1, 2, 3, 4, 5, 6, 7, 8. The domain of this particular function, now I know this table represents a function because every input has exactly one output. 1 goes to 5, 2 goes to 6, 3 goes to 7, 4 goes to 8. So I know this is a function. Now it has a domain of 1, 2, 3, and 4. I know that because these are my input values. I plug in 1 and I get 5 by some transformation, and we could write this equation if we wanted to, but we're going to keep it discrete just because it makes it easier to talk about. Now, when we have a table like this, it's very easy to find the domain. I simply look at what are my input values. Now, when we get to something that is continuous, meaning it's a function that carries on, there are no breaks, it goes on forever and ever, determining the domain is a little bit more complicated. So let's define a function, f of x equals 1 over x minus 1. Now for this type of function, it's a lot harder to determine what the domain is by looking at what can I plug in. So I could just start plugging in numbers over and over and over again and keep going that way. The only problem is there are an infinite numbers to try. So in this case, it's actually easier to look for what can I not plug in the equation. Now, when we're looking at functions, at least when we're considering real values, there's a pretty straightforward test. The first case we are going to avoid is having a 0 in the denominator. If we were to try and do 1 divided by 0, we can't do it. We say this is undefined. So when we're working with a continuous function like this, we're looking to see what x value or what value would make this 0 in the denominator. So when I have a variable in the denominator, what I'm going to do is I'm going to take my denominator and set it equal to 0. By solving this equation, I can determine what value I cannot plug in. So looking here, I know that I cannot plug in 1. Here's why. Let's evaluate it. So if I do f of 1 minus 1, it gives me 1 over 0. And this is undefined. So the input of 1 doesn't have an output or has an output of undefined. So we say that this is not part of the domain. So there are two ways you can write it. You could write it using interval notation or the standard real numbers. I'm going to write this in interval notation. So what I'm going to say is that my domain goes from negative infinity to 1 with a parenthesis because we're not including 1. And then it goes from 1 to infinity. This is interval notation, and this states that my domain is all reals except for 1. It's the only thing I am excluding. So that's one way to find the domain of a continuous function, is by setting the denominator equal to 0 and finding what gives us 0 in the denominator. Now there's one other case that we could run into, or another issue. So let's define the function g of x equals square root of x plus 5. Now, looking at this function, again, I could just start plugging in x's and getting y's out and keep going and going forever. That's going to take a while. So what we're going to do is see, is there any values that I cannot plug into this? Now, first, let's talk a little bit of Algebra 2. We need to understand what this is, the square root of -1. This is I, and is the basis of what are called complex numbers, which have a real and imaginary part. Now, when we're finding the domain of continuous functions, we want to keep our values real, meaning we can't have any negatives underneath the radical. So what I'm going to do is similar to this here when I found 0. I'm going to take the radicand, and that's just a fancy term for the part underneath the radical. And I'm going to take that and set it greater than or equal to 0. Now, the reason I'm setting it greater than or equal to 0 is because either A, x plus 5 could be 0. We could find the square root of 0, no problem. Or x plus 5 is greater than 0, meaning that it's positive. So I solve this inequality, minus 5, minus 5. So I get x is greater than or equal to -5. So this is the domain. We looked for what can't I have. I can't have negative numbers under the radical. So every value from -5 up will work. It will give us a positive value under the radical, which we then can evaluate. So we write our domain using interval notation. Domain is -5 to infinity. Now this bracket means in interval notation that I'm including -5. So this says I start at -5 and I go towards positive infinity. So this means the same thing as this as far as my domain goes. So when we're calculating domain, there are two things we do. We try and avoid having a 0 in the denominator. We also try and avoid having a negative under the radical. So that's about everything we need to talk about with domain. Now let's get to range. Now range is the output values of a function. And a lot of times we refer to this as the y values. So if I were to go back and let me redraw my table from earlier. So I had this example, x, y, 1, 2, 3, 4, 5, 6, 7, 8. My range here would be the values 5, 6, 7, 8. Now calculating range is a little bit more tricky than calculating the domain. Domain, there's a very concrete algebraic way of finding it. However, with range, it's a little bit tougher. It has to do a lot with asymptotes and understanding limits just a little bit. Now, since this video is for a pre-calculus class, I'm going to use a graphing calculator to help illustrate how to find the range. Now, let's define a continuous function. Let's define f of x is, we'll keep it simple, x squared plus 1. X squared plus 1. So I'm going to find the range using a graphing calculator. So in my graphing calculator, I'm going to go ahead and just type my equation, x squared plus 1, and hit graph. Now this is what the graph of my function looks like. X squared plus 1 is a parabola. It opens up, and it has a vertex at 0, 1. Now what we're going to do for the range is we're going to look and see, okay, what are the y values that are represented here? Now again, it's kind of hard to just start picking y values and see if they're there. It's easier to look for boundaries. Now looking here at this parabola, I'm going to write on my calculator a little bit, I can see that it starts at 1. The lowest y value I have is 1. Now I can be for sure that 1 is part of my range because if I take this function, if I evaluate f of 0, 0 squared plus 1, I get a value of 1. So 1 is definitely in my range. And looking at the rest of my graph, I can see that all my values go up from here. So all my y values are going to be bigger than 1. So what I do is I say my range is from 1 to infinity. So it starts at 1 and it goes up towards positive infinity. Now I'm going to do one more range example. Let's define g of x as 1 over x. Now for domain, we have 1 over x. Well, the only value we can't plug in is 0. So just a little refresher. My domain here is negative infinity to 0, not including 0. So that's what this interval notation says, to go from negative infinity to infinity, but exclude 0. Now let's talk range. So I'm going to come in here in my calculator, and I'm going to type in my function 1 over x graph. So this is my function. I'm going to zoom in a little bit so I can get a much clearer picture. It looks something like this, 1 over x. Now again, it's a little challenging to find the range. There isn't a straight, clear-cut way of finding range without knowing a little bit more math. Since this is pre-calculus, it's pretty limited. So looking at this graph, I can see that it looks like there's a gap. It looks like there's one y value I'm not going to hit. So coming down here, it looks like this curve is getting closer and closer to 0. Same thing here. It looks like I'm getting closer and closer to 0, but I'm not going to touch it. So what I'm going to do is I'm going to test and see, is 0 part of my range? So here's how we do it. Since range represents the y values, I'm going to replace g of x, which also represents y, with 0. And I'm going to try and solve it. Well, to solve this, I'm going to multiply both sides by x. So I get 0 equals 1. Well, that's never going to happen. So I cannot find any x value that will give me a y value of 0. That's one way to algebraically test it. So my range is the same as my domain here. It's everything but 0. So that is a brief discussion on the topics of domain and range. If you like, subscribe, and if you have any questions, feel free to send me an email.